Today is Wednesday, November 4th, 2020. Today we will review our Google Meets, review our class norms, review and recite our mission statement goals, discuss our learning objectives, work on our science warm-up, and then continue working on our potential and kinetic energy speed lab. Our Google Meets etiquette is to make sure that you show up on time. Make sure you work in a quiet place. I don't know whoever it was who just unmuted, but it was awfully loud. So find a quiet place, and if you can't find a quiet place, maybe start asking for some headphones. I know it sounds crazy because some of you think that y'all can sit there and work with the TV going on in the background or a party going on in the background. And scientifically speaking, it's not possible to concentrate with noise. So although work can get done, it's not going to get done the way that it needs to get done. So there's a difference between just doing and doing well. You want to do well. Make sure you have all materials and supplies. Make sure you mute your microphone and listening. Your video needs to be on, just like Ms. James just said. It's a district request that you turn your video on. Guys, when I am recording, I am not recording your pictures. Not recording your pictures. I'm not even recording the screen that the meeting's on. I'm recording a separate screen. What you see in the presentation is what's being recorded. So if you notice in the presentation, none of you guys are showing, so there's no reason to turn your camera off. Make sure you use the nod or raise your hand if you have a question. Wait for me to say your name before you unmute and speak, and then leave at the end of the meeting. Our class norms are to be kind in our tone, words, ideas, and thoughts. What's in our thoughts is also what's in our heart. Our heart needs to be kind. Be respectful. Make sure you're listening and looking. If you are in your screen, like jumping up and down and running around, trust me, it takes away the attention from others. If you're doing this with your screen, guys, that's noticeable, isn't it? It's extremely noticeable, which is why you need to make sure that your computer is on a solid platform so it's not moving around everywhere. You need to be sitting at a table, at a desk, somewhere where your computer is stable so that we don't get distracted by all the movement of the computer being in your lap. Make sure that you're working and staying on task. We're here to work. Our mission statement, are y'all ready? We will work together as friends and family in Mrs. Metz's class to gain more knowledge, to work, and to learn. So we can all be successful. We will listen to each other, help each other, and encourage each other. We will make things happen and show the world we will not accept anything short of the best. Good job, guys. Thank you so much for those of you who are always involved. Our class goal is 100% of Mrs. Metz students will show growth on unit assessment throughout the 2020-2021 school year. They will accomplish this goal by being purposeful and intentional with their time and learning. Today's objective is you will explore the relationship between the application of a force and the resulting change in position in the motion on an object. I will know that you have learned this by, I'm missing a word, by reading your answers to the following questions. How did you change the force of the car, and what was the result of this change? So remember, we are continuing to explore our ramps and understanding how we change the force, like what's changing the force, And then what's the result of that change, right? All right. I need to fix that. So our warm-up, just to go over our champs real quick. You need to make sure that you're at a level 0. You raise your hand and wait patiently if you have any questions. You're reading, thinking, solving, writing. Stay in your spot. Stay focused on your work so that we can all succeed. Your warm-up today, and I'm going to read this and then I will show you how to open it. Your warm-up today is a student combined powdered juice with water. The student left the mixture on the windowsill in an open jar. Explain what changes were most likely observed to the mixture after several days. So not just one day, but several days of water being left by a window in the Texas heat. Think about that. Think about what would happen. And then, guys, one of the things I want to make sure that you're doing is that when you're answering these questions, they need to be in complete sentences. They need to be in complete sentences. Some of you are not writing with capital letters. Some of you are not using punctuations. Guys, I'm going to start taking grades on these warm-up, and complete sentences is going to knock you out of the game. Complete sentences. You have to write complete sentences in your reading and writing class. Why wouldn't you do it here? It's extremely important that you understand complete thoughts. Number 2, students test 3 different substances to see if they will form a solution. How will the students know when a solution is formed? How will you know a solution is formed? To open it, so right now, you all should be clicking on your HEB ISD class link, and then scroll through your apps to open up your Canvas. Once you have opened up your Canvas, you need to click on the Mrs. Metz card. Once you are in the Mrs. Metz homepage, you can either click on modules over here on the left, or you can scroll down to week 12, because we're in week 12, right? You can tell by the dates. We are on November 4th. So November 4th falls between November 2nd and November 6th. So click on the week 12. And we're working on the warm-up, so you're going to click on the week 12 warm-up. And it should bring you to your old file. It should have been saved, and you should see your work that's in it. Thumbs up if it worked. All right. So it looks like it's working for most of you. Okay, Chloe, you've got to learn to raise your hand instead of just unmuting, because I want to give you my undivided attention, but I can't do that when you just unmute and talk. It's kind of just a shock. So what were you saying? What's going on? What's wrong? Oh, okay. Thank you. But Chloe, I shouldn't need to present at this point because you guys are listening to what I'm saying to do. Like, you shouldn't be looking at the meeting right now. What you should be looking at is your warm-up. Yes? If you are looking at the meeting, then you are not doing your warm-up, and that's a problem. So, everybody should be looking at Wednesday in your week 12 warm-up. I am going to give you 5 minutes to work on this. Please make sure that you are typing or writing incomplete sentences. Capital letters, punctuations, more than one thought. You guys are brilliant. Show me your brilliance, please. You have 5 minutes and go. All right. Number 1 says, a student combined powdered juice with water. The student left the mixture on the windowsill in an open jar. Explain what changes were most likely observed to the mixture after several days. Raise your hand if you want to share what you put. Tyler.
Eventually, the powder will dissolve in the water and causing a solution.
Oh, look at all of that. Okay, so you put eventually the powder will dissolve in the water and create, make, what'd you say? Create?
And cause.
Cause. Love it. And I need to do those little typing things that y'all do. Don't y'all have like a typing app somewhere in your class?
No, that's Grammarly. That's an ad thing. I don't do that. Whenever I spell things wrong, it usually gives me this red mark below it.
Oh, no, that's not what I'm talking about, though. I know what you're talking about. No, I'm talking about, there's a practice typing website that some of the students here in the classrooms go to when they've finished all their assignments. Anyway, we're not talking about that. Sorry. That's totally my fault. Raise your hand if you have something different. Yes. Sorry, I didn't mean to distract from what we're actually doing. So, again, does anybody have anything different for number 1? What would happen after it sat in the windowsill? Scarlett.
I said, and I wasn't really sure, but it said that the powdered juice would stir in the water after a few days, or the cup would get really hot and the water would taste warm. And so it would get all mixed up with the water. And then I drew a picture with the cup and the table.
Okay. Huh. Anybody have anything different? Talia.
I said it will turn into a sweet solution because sugar dissolves in water, so it will be hard to separate.
So y'all all basically have the same idea. So I guess I think a little bit differently. You guys all said that it would be a solution. I'm thinking after it sits in the windowsill for a few days, that the water would start to evaporate and leave a little bit of the powder behind. Sujab.
That's right. So it's like when you left the jar open, it would like evaporate and there will be like frogs. That's what I put.
Yeah, that's what I think. After leaving the jar open for a few days, the water would begin to evaporate and leave some powder behind. If you have your original answer as the powder will dissolve in the water and cause a solution, leave it. But I highly recommend you add also that after a period of time that the water will evaporate and leave the powder behind. Because it will. It will. So make sure you add that to the warm-up. Don't leave it blank. Add it in. All right. Number 2, students test 3 different substances to see if they will form a solution. How will the students know when a solution is formed? So I'm going to start my sentence. Guys, I am typing all this in because I am trying to model for you what you should be typing. And I don't mean the exact words. Don't change your answers to the exact words. The key here is that you notice I'm using capital letters, complete thoughts, complete sentences, punctuation, right? These are the things that you need to be doing. You need to be writing in complete sentences. So I'm going to put, these students will know a solution is formed when, how will they know that a solution is formed? Raise your hand if you can tell me. Hassan, how will they know when a solution is formed?
They mix stuff together.
What happens after they mix it together?
It makes a solution or it makes a mixture.
Okay, how do they know it's a solution though? What are the characteristics to make it a solution?
Water and salt.
That's not a solution. That is a mixture. How do they know that a solution has been formed? Scarlett. Oh, sorry, Tyler. Scarlett.
You might know when the solution is formed because all the three substances they put in there, it will dissolve in water.
Because, oh, good. So because all the what?
All the three substances they have
All these substances will, and I'm going to put that in caps, dissolve because what's the key word here? Dissolve. So, Hassan, when you mix items together to make it a solution, it creates a new substance. So it dissolves. It doesn't, like, sand is not going to dissolve in water. Salt dissolves in water. Sugar dissolves in water. You might put like Kool-Aid. One of the things we talked about the other day was Kool-Aid. Kool-Aid dissolves in water. So if it dissolves in water, it creates a solution. If you have to use evaporation to separate it, it is a solution. Okay? So this question was really trying to get you to hone in on the idea of knowing a substance means that knowing it's a solution means that the substance will dissolve. Please remember that knowing it is a solution means the substance will dissolve. Thumbs up, everybody understands? All right, fantastic. I am going to delete my text boxes because I do not want them to show up for the other classes. And then we are going to go back to our home page. So when you are in the Cami file, before you close it, although I think with you guys, on Monday it was working, if you go up to the submit, y'all can't see that. Hang on, let me share this. So, you can either be listening to me right now before you close the Cami file, or you can come back to the meeting and look at what I'm doing and then go back and do it. But when you are looking at this Cami file, there is a button here that says submit. You're going to click it. And if you scroll down, there's a save now. This save now allows you to save the changes that you have made without submitting it, because we're not going to submit warm-ups until Friday. Okay? Questions? Go ahead. What, Tyler?
What about the auto save?
It wasn't working for students in the classroom for some reason.
Oh.
It's supposed to, but I had some of them on Monday that were like closing it, and then when they opened it back up, it was gone. So another safe way to do things is to save it now just to double check and make sure so you're not having to type it in again. Because if it does all disappear, and when I do start taking grades on warm-ups, you are going to have to do it again. And we don't want that to, I don't want you to have to do 3 times the work, right? I mean, that's not fun for anybody. All right. So, excuse me, let me stretch. Okay, so going back to your Canvas page, you can either watch what I'm doing for a minute and then go do it, or you can listen to my voice and follow along while not looking at the meeting. Totally up to you. But you're going to go back to the Mrs. Metz homepage. It's just the easiest thing to do. Scroll down to week 12. And open up the week 12, day 1, Monday through week 12, day 4, Wednesday, Potential and Kinetic Energy Speed Lab. So I'm clicking on that to open it. I'm going to scroll down. If you notice, I added the video lesson from Monday. So if you missed the lesson on Monday, it is here. I am currently recording today's lesson, so it will be in here by either the end of the day today or first thing in the morning. The instructions say, so if you are listening to me, the instructions say to click the link below to return to the original assignment with the lab file. That is the only reason why you are returning back to this assignment is to open up your lab files. So I'm going to click on week 11, day 4, Thursday, Potential and Kinetic Energy. Clicking on the green link. Now, we've already gone through all these instructions. So what I'm doing is I'm scrolling all the way down so that I can load my week 11, day 4, Thursday, Potential and Kinetic Energy in a new window. This is your lab that we were working on Monday. So go ahead and open it. And this is what it looks like. For those of you who were watching the meeting, I am going to give you 2 minutes to open up your lab file. You have 2 minutes to open up your lab file. And go. Is anybody having any trouble getting this file open? Okay. You got about 30 seconds left and we're going to move along. All right. I want to go back because you should have the variable you are testing. We typed that in. Yes. Can somebody raise your hand if you're willing to read it to me? Tyler, unmute and read to me what we wrote in for the variable you are testing.
The variables we are testing are the distance the car traveled based on the number of books in the stack.
Thank you. The variables we are testing are the distance the car travels based on the number of books in the stacks. All right. All right. And then, what did we say for explaining how we're going to do this test? Scarlett.
I feel like the same for every test, but except for test will only stack one book and learn to rank on it. Words of Hot Wheels track another book and anything you can think of to create a rank. Then I release a car or object to roll down the ramp. Next, I will measure the distance from the end of the ramp to the rest of the position of the car or object. And do that for every single one.
I'm not going to retype all that. That's a lot. Wonder if okay. I'll have to figure that out. All right. I should have taken a picture of it last week. Oh, well. Okay. So I'm going to go back and I want to make sure, I'm going to share something with you real quick. I want to make sure that we understand the two questions we are trying to answer here is how did you change the force of the car and what was the result of this change? Okay? How did we change the force of the car and what was the result of the change? And I'm going to bet you guys already have an idea of how we're changing the force of the car and what the results are going to be. But we are going to prove all this, okay? We're going to prove all this. So let me go back to this. And so what's going to be happening is, and I'm not going to be able to do both. Okay, I am going to have to write it down on a separate sheet of paper because I'm going to be presenting from the iPad. So I am on a separate sheet of paper. See this? I am going to be basically filling out this table. Okay, I'm filling out this table here because that's what we're going to be doing. We're going to be stacking a number of books, right? And we are going to be doing several trials. And then when we're done, I will calculate the average for us. We will talk about how to do that because it's math and you kind of have to know how to do it eventually. And then we will go through and talk about and analyze our results, right? All right. Man, I may have to change this. I'm going to change the lab sheet. All right, so give me a second to see if I can switch things over. Hang on just a second. good. Y'all can see that. All right. Let's see if we can get this to work. Hang on a second. We're having some technical difficulties here. All right. So I'm going to set this on the floor. Oh, I'm going to flip this. Alright, so y'all are going to see this kind of coming at you. We're going to see how this works. Hang on a second. I'm still having to... Alright, so can y'all still hear me even if I walk away? Yes? Okay, fantastic. So, what I'm doing is... That's not the book that I want to use. I am going to use a few different books that we have. Give me a second to grab them. But I want them all to be the same. I'm using the same books. So the book that I'm using is going to be, I have these, they're math workbooks, investigation workbooks, and these are the books that I'm going to be using. I have Hot Wheels tracks, but remember for the first one, we are going to use one book. Do you see that? One book. So we said we're going to stack one book. We are going to lean the track up against it, right? Make sure it's. And then I have a Hot Wheel car, okay? I have a Hot Wheel car. So I'm going to release the Hot Wheel car down the track, and then I'm going to measure how far it goes. Y'all ready? Okay. Okay, it doesn't really get off the track, but I'm still going to measure from the length of the track. So let me grab a ruler. And I still have my little notepad. See, I have my notepad that I'm recording. And so let's see if I can measure the distance in inches. So it went about 30 inches. So I'm going to say that on one book, trial one, it went 30 inches, okay? So I'm going to show you all this. So it went 30 inches. Where's it at? So my graph looks a little bit different than yours, but you kind of get the idea that I have book one, trial one, right? Book one, trial one went 30 inches. So in your Cami lab, you're going to have for book one, trial one, it went 30 inches. And then I'm going to do it again, and then I'll show you, okay? So here we go. I'm going to do it again. And this is also something that you can do at home, and it doesn't even have to be a Hot Wheel car. You could use something like a ball. I might be able to find a small ball somewhere that I can use a small ball. So I'm going to do it again. Y'all ready? This time it went... This time it went 29.5 inches. 29.5 inches. So in my and again, remember I had to recreate my table real quick. So for book one, trial two, I'm going to write 29.5 inches. See? So for book one, trial two, I'm writing 29.5 inches. Y'all with me? All right, let me see. I'm having to go back and forth because I can't see. Are y'all doing good? Yes? Okay, fantastic. All right. Let me do it one more time with one book. for one book, let's see how far it goes. That time it went 29 and, nope, 28 and, let's see, that's 1, 2, 3, 4, 5, 6.75 inches. So it went 28.75 inches. So let me show you. So for book 1, trial 1, it went 30 inches. For book 1, trial 2, it went 29.5 inches. For book 1, trial 3, it went, 28.75 inches. Okay? When I'm done doing these, I will go back and I will type them into Cami. Hopefully you guys are able to keep up. All right, so now, the second one, I'm going to stack 2 books. We're going to stack 2 books to see what happens. Okay, so for 2 books, before I do this, hang on a second. Raise your hand if you can tell me what you think is going to happen with the force. What do you think is going to happen with the force? Cruz, what do you think is going to happen with the force?
I think we'll jump high.
So you think the force is going to go up?
Mm-hmm.
So what do you think is going to happen to the car?
Go crash to the floor.
You think it's going to crash to the floor? I guess we'll see, huh? We're going to see what happens. Tyler, what do you got?
I think what's going to happen is it's going to go further, and once it hits the ground, it's going to cause way more friction than it did on the track. And that will slow it down.
Okay, so you think the carpet has something. Think about that. Don't let go of that thought. Don't let go of that. Don't let go of that. Because we might talk about that in a minute, but I'm going to go test this, okay? I'm going to go test this. Make sure I have everything. All right. So now I'm going to test this one and see what happens. All ready? Whoa. So that one went off. I am going to put this right here. Whoa. I'm actually going to get a second one. And keep measuring. That was 36, 37, 38, 39, 40, 41 and a half inches. So for book 2, trial 1, it went 41 and a half inches. See? So for book 2, trial 1, it went 41 and a half inches. And then I'm going to try it again. I'm going to do it again and see how far it goes this time. Like a kid playing with toys. Okay. So 36, 37, 38, 39, 40, 41 and a half inches again. So for 2 books, trial 2, it's 41 and a half inches again. 41 and a half inches again. I'll do it one last time. Okay. Trial 3. Oh my goodness. This time it went 42 and an 8. 42 and 1/8. So that would be 42. 42.125 inches. So an 8 is that an 8 or whatever? It's close enough. So 42, you could just say 42. Let's just say 42. No, it's a little bit more than 42. So it went 42.125 inches. And again, here in a second, I will go type this into our lab sheet so you can see it a little bit better. All right. I'm going to try 3 books. Hang on a second. I'm going to do 3 books. So, coming back over here, we did Hassan. Do you have a question?
Yes, it's about the Hot Wheels. So, I think the books, so like the higher depths, the more like friction it goes down. Force, I mean.
Okay, repeat what you just said.
So, like, the stack of books you're putting in, like, the Hot Wheels set.
Okay.
So, you know how it's going down fast?
Yep.
It's because you're making, like, the Hot Wheels track higher and higher, which makes the car go down faster and faster.
Yes, I think you're already answering our 2 questions, aren't you? But we're gonna do the experiment to prove it. So, before we move on, we've noticed that by adding a book, the car went further, right? Do we think this trend is going to continue when I add that 3rd book? Yes? Tyler says yes. I think I agree. Hang on a second. I'm noticing that somebody's coming in and out of the meeting, and so it's changing what I'm recording. So I'm having to move my square. All right, so I'm going to go over here and I'm going to add a book. Then I'm going to do 3 more trials, and then we'll come back and put it in the lab sheet. All right. Let me set up my ruler to measure. It's so much easier when it's just sitting here. I love it. All right, so let's do first trial. See what happens. Whoa! So 36, what is 36 plus 18? 54? Wow.
I actually thought it was going to land there.
You did? Look at you being all scientific and thinking ahead. That's fantastic. So this time it went 54 inches. That's crazy. That's a significant difference with that 3rd book, isn't it? Huge. So let's try it again and see what happens. This one went a little bit shorter. This one went 36 plus 16, 52 and 52.75 inches. So this one was a little bit shorter, 52.75 inches. But I honestly think it has something to do with the fact that the car ran into the ruler, right? So what did the ruler do? When the car ran into the ruler, it created what, which slowed it down? Can somebody unmute and tell me?
Friction?
You're exactly correct. It created friction. So what happens when you create friction on something? It does what to the object?
Slows it down.
It slows it down. All right, 3rd trial. This one went 54 inches again. 54 inches again. Although, I'm going to do a 4th one. I'm curious to know what would happen if my ruler is not there. And then I'm going to measure. See, scientists get curious, don't they? I want to know what factors are affecting my results. Oh, it actually went shorter. It went only 52 inches once I moved the ruler. So you would think, scientifically speaking, the ruler apparently didn't have that much of an effect on it, but it was a good conversation, right? So give me just a second to clean up my mess.
If your floors weren't carpeted, it wouldn't have that much friction on it, which would probably go further.
Oh, I totally agree with you. Hang on to the next part. So hang on a second. I think I'm able to just get out of this meeting. What happened? All right. Okay. Hassan, did you have another question? The ruler, and it actually only went 52 inches. So not having the ruler there really didn't change the results any, right? It still kept it the same, which is, it's fine. All right, so let me go back to present this.
What I actually believe is, like, what if you put the hot wheel car on the ruler?
That's a good question. It might change something. I don't know if I honestly don't know if the Hot Wheel car will stay on the ruler. That would be my first concern, is that it wouldn't even stay on the ruler. All right. Okay. Hang on. Let me see if I can. There we go. All right. So I'm going to go ahead, and you guys should have this typed into your lab sheet, but I'm going to go ahead and type in the measurements that we took in our lab sheet. So I'm going to do 30 inches. Trial 2 for one book was 29.5 inches. Trial 3 is 28.75 inches. And then I will calculate the averages here in a second, and I will tell you how I'm doing that. For book 2, trial 1 was 41.5 inches. Two books, trial 2 was 41.5 inches. Two books, trial 3 was 42.18 inches, which I'm putting 42.125 because that's what an eighth is. And then I will calculate the averages here in a second. For 3 books, trial 1, it was 54 inches. 3 books, trial 2 was 52.75 inches. Trial 3 was 54 inches again for 3 books. All right. I'm going to use my handy calculator to calculate the average. So to calculate the average, what I'm doing is I'm adding all 3 trials up and dividing it by 3. That's going to give me the average. Chloe.
Never mind, I can see your presentation for a second.
Oh. But you can see it now? Divided by 3. So the average for one book is 29.42 inches. 29.42 inches. And again, what I did is I added up all 3 trials and divided it by 3. Okay? Added up all 3 trials and divided by 3. So please make sure you add that into your results as well. Okay? Since we're doing this together, you should be able to have it in your results as well. For 2 books, let me calculate that one. So I'm adding all 3 of those up again and then dividing it by 3. And it's going to be 40, you can't see what I'm typing, 41.375 inches. So make sure that you include the average of 41.375 inches. And for 3 books in a stack, let me calculate that average. So again, I'm adding all 3 trials up and then dividing it by 3 to get an average. And the average for 3 books was 53.18 53.58 inches. 53.58 inches. So let's, 53. I'm going to give you, what? All right. What was that? Are y'all typing this in? Yes? Okay. Then I will give you, what? Do you need like 3 minutes to type it in? Okay, I will give you 3 minutes to type it in. Okay, 4 minutes, because that's what's already in my watch. What, Talia? Or I don't know who that was. Talia, do you have a question, dear?
I don't have the same thing.
So, this is the point where I usually let go of the meeting. So, what I want you to do is take the rest of your time right now. Add your lines, right? Add your lines roughly the same distance from each other. Add in your 10 inches, your 20 inches, your 30 inches, your 40, your 50, your 60, and your 70. When we come back tomorrow, we will open this back up, okay? We're going to open this back up, and then we are going to graph our results and talk about what happened so that we will continue to answer the question, how did we change the force, and what was the result of changing the force? Thumbs up? You understand that you need to finish this graph. Yes, when we come back tomorrow, this graph needs to be labeled and updated, so all we have to do is graph our data. Thumbs up? All right. Every single one of you need to listen to me right now. I know that you and I are hanging up from this meeting, but you need to make sure that you are going on Miss Harani's Canvas page and getting in her meeting. Please do not forget that you have a math meeting you need to attend, you have a reading and writing meeting that you need to attend, and then you're going to come back to me at social studies. Some of you come to the meeting in the morning and do not show up to any other meetings. Guys, you have class all day long. You hang up from this one. You need to go connect with Miss Harani. When you're done with Miss Harani, connect with Miss Lindsay. When you're done with Miss Lindsay, come back to me. Thumbs up? Perfect. I will see you guys at 2:25. Bye.